So hello everyone, this is Saran Nandula. So I'll be dealing with geography. So let us start with the first section of geography, that is geomorphology. Now we have geomorphology and then we have climatology, oceanography, Indian geography. We'll also discuss human and economic geography. So let us start with the first section, which is geomorphology. Okay. And in geomorphology, we are going to start with the first chapter, which is the solar system and the Earth. So, any questions anybody has before I start this session? So, do you have anything to ask me, or so if you have any doubts, you can ask me now. Any questions you have? So, are you getting this sound? I hope you are getting this sound. I hope there is no issue. Okay. Now, so I'm just waiting for you guys to raise any questions you have. Good evening, everybody. So, thank you for joining me. Good evening. Good evening. So, do you have any questions or any doubts in your mind? We are going to start with geomorphology, and we are going to start with the first chapter, which is solar system and the Earth. Okay. So, yeah, this session is the fresh one. This is the first session of geography. So, I'll be covering the NCRTs also as part of this course. But anyway, if you read NCRTs, it'll be good for you because you'll get more conceptual clarity, more grip on the basic concepts. So, I highly recommend you to read NCRTs, but I'll be covering the NCRT basics also as part of this course. So, you don't have to worry about anything. Okay. Fundamental difference between geology, geomorphology, and the related terms. Yes, we'll get there. Please don't worry, Mudit. We'll get there. So, geomorphology is all about the structure of the Earth. Okay, so in geomorphology, we are going to discuss about the first solar system concept, and then we'll start discussing about the interior of the Earth, the various layers of the Earth, and then we'll start discussing about plate tectonics, the continental drift theory, plate tectonics, and the evidences for that. And then we'll also discuss about the various landforms like mountains, plains, plateaus, valleys, different types, and then the different drainage patterns, different types of soils. All these will be covered in geomorphology and much more. Okay. Now, so you're not able to see me clearly. Guys, are you facing that issue? Okay. So, do you want me to move the screen to the left side? Okay, we'll do that. Okay, so now is it fine, guys? I hope it's good now. Okay, so let me start the session. So I hope there are no more issues, no more doubts. So first we'll go very slow, okay, and then slowly we'll pick up the pace. So let me just start. First, let us start with the definition of solar system. Now, the solar system consists of our star, the sun, and everything that is bound to the sun by its gravity. So, in the solar system, first we have the 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And then we have dwarf planets or small planets such as Pluto. I'll also explain to you why Pluto is a dwarf planet. Please don't worry about that. And then we have several moons or natural satellites. Okay? And then we also have millions of asteroids, comets, and meteors. All these are the components of solar system. We will discuss about each and everything in detail. So just don't worry about anything. So I hope now it is fine without any issues. Okay. Now, so just to get this wonderful image of solar system, guys. So we have sun, our star at the center. And then we have the 8 planets starting from Mercury. This is Mercury, Venus, Earth, and Earth's moon is also shown. And then we have Mars. Now, between the orbits of Mars and Jupiter, you have asteroid belt. And then Jupiter, which is the largest planet of the solar system, and then Saturn, Uranus, Neptune, and this tiny, object here is Pluto, which is a dwarf planet. And this thing here is a comet. So all these are the components of solar system. Clear? Now the sun is the nearest star to the earth. We all know that sun is the nearest star to the earth, and sun is the most important source of energy to the planet earth. Now without sun, can life exist on the planet? Absolutely not. So sun is very crucial for the existence of life on the planet earth, and sun is the main source of heat and light for the entire solar system. Okay? Now, stars. Sun is a star, and stars produce their own heat and light. So, inside the core of a star, thermonuclear fusion happens. So, due to this thermonuclear fusion, a lot of light and heat are released into the space. Okay? So, stars produce their own heat and light, and they are made up of very hot gases. And sun is the ultimate source of heat and light for the entire solar system. Okay, not only for the earth, but for the entire solar system. Now, so any issues anybody is facing? I hope it is good now. So any more issues anybody has? No issues? Okay. So let me just continue. Now, the planets, besides revolving around the sun, they also rotate on their own axis. Now, let us just try to understand the basic difference between rotation and revolution. So, first, rotation. Rotation is the spinning of planets on their own axis. Now, what exactly is an axis? So, this imaginary line here is axis. So, axis is nothing but an imaginary line that passes through the center of the planet. Axis passes through the north pole and the south pole of a planet. Okay? So, every planet rotates about its axis. So, please keep that in mind. Clear? Now, the axis of the earth is inclined. As shown in this image, the axis of the earth is inclined. It is not straight. So, please keep this in mind. Anyway, we'll discuss about this in detail in climatology when we discuss about different seasons. But as of now, please don't worry. This is the first class. I just want you to be comfortable with me, and we are just discussing the basics now. So please don't worry about anything. Now, the axis of the earth is inclined, and the earth rotates from west to east. This is the direction of rotation or the direction of spinning of the earth. Clear? Now, what is revolution? So just look at this beautiful animation which shows revolution of the 8 planets in the solar system, starting with Mercury, which is the closest planet. Okay. Now, all the 8 planets revolve around the sun in fixed paths called orbits. So you can see the orbits of all the 8 planets, right? So these orbits are fixed paths. The planets do not deviate from their orbit. The planet will only move in that fixed path, which is called orbit. As simple as that. Now just look at planet Mercury, which is very close to the sun. Mercury only takes 88 days to finish one revolution around the sun, because Mercury is very close to the sun. Now let's just look at Neptune. Neptune takes 165 years to complete one revolution around the sun. I hope you're able to compare these both. Mercury, which is very close to the sun, it only takes 88 days to finish one revolution. But Neptune, which is the farthest planet, it takes 165 years to finish one revolution around the sun. So what is the logic here? What is the thing we have to understand here? Mercury, which is very close to the sun, is under tremendous gravitational pull of the sun. So that is the reason Mercury revolves around the sun much faster. But Neptune, which is very far away from the sun, it is under less gravitational pull from the sun. Gravitational pull of the sun is there, but it is less for Neptune because Neptune is very far away from the sun. So Neptune moves much slowly around the sun. And by the time Neptune finishes one revolution around the sun, many planets would have already finished multiple revolutions around the sun. Okay, so that is the logic. If a planet is very close to the star, the planet will be under severe, very strong gravitational pull of the star. So then the planet has to revolve much faster. So that is the logic here. Clear? So any doubts anybody is having? Okay, so if you have any issues, if you have any doubts, please ask me now so that I can clear it right now. Okay, so I hope everything is fine and I'm just proceeding with the topic here. Now, the solar system is part of the Milky Way Galaxy. We all know this, right? Milky Way Galaxy is our home galaxy. Now, what are galaxies? Galaxies are very huge and they contain billions of stars, billions, and huge clouds of dust and gases. So, it is actually from these clouds of dust and gases the stars form. So, galaxies contain huge clouds of hydrogen gas. From these huge clouds, the stars actually form. Okay? And there are billions of such galaxies in the observable universe. So just imagine how small we are in this universe. Now, Milky Way Galaxy, our home galaxy, is a spiral galaxy. Okay, so this is one of the best representations of the Milky Way Galaxy. It is spiral. So galaxies have different shapes basically. You have spiral galaxy, and then you have elliptical galaxy, and also some of the galaxies are irregular. They don't have any proper defined shape. Okay? Now, galaxies are not static, they are dynamic. Galaxies are in motion like this. Okay? Now, the sun is roughly here, and the sun moves around the galactic center. The sun revolves around the galactic center. All the stars revolve around the galactic center. Now, sun takes roughly 225 to 250 million years to finish one revolution around the galactic center, and it is called one celestial year or cosmic year. So please keep this in mind. The time taken by the sun to finish one revolution around the galactic center is roughly somewhere between 225 to 250 million years, and it is called one cosmic year or celestial year. Now, scientists say that in the center of the galaxies, there are supermassive black holes. There are very, very large black holes, which are holding this entire system together by their gravitational pull. Okay? Now, I just want to tell you one thing. I just want to tell you how small Sun is compared to Milky Way Galaxy. Okay? So before that, do you have any doubts? No doubts? Okay. So I hope you're enjoying this session. So just drop in a comment if you're enjoying this session. I just want everybody to feel comfortable. I just want everybody to enjoy this session. Only if you enjoy this session, you can learn something. So that is my main target here. Okay, now let me just tell you something which is very interesting. So if you reduce the size of sun to a white blood cell, now we know that we have white blood cells, right, in our body. So if you reduce the size of sun to white blood cell, then the size of Milky Way Galaxy will be the size of United States. Just imagine. Let me just repeat this one more time. If you reduce the size of sun to that of a white blood cell in our body, then the size of Milky Way Galaxy would be that of the size of United States. So Milky Way Galaxy is so huge. Okay? And the sun roughly takes around 225 to 250 million years to finish one revolution around the galactic center, and we call it as celestial year. Clear? Now, let us go to the next concept, which is astronomical unit. Now, the average distance of the Earth from the Sun is this 149,642,000 kilometers. So, roughly, you can call it as 150 million kilometers. Clear? So, this 150 million kilometers is represented as one astronomical unit. So in very simple terms, one astronomical unit is nothing but the distance between the sun and the earth. It is roughly 150 million kilometers. Clear? Now, why do we have this unit? What is the use? Just look at the statement. It is very convenient to use this unit in describing the distance of other planets from the sun. For example, Jupiter is 5.2 astronomical units from the sun. See, all the astronomical distances are very, very large. So that is the reason we have taken the distance between the sun and the earth as one astronomical unit, and the distance of other planets from the sun can be described in terms of astronomical unit. For example, Jupiter is 5.2 AU, far away from the sun. Clear? So I hope this concept is clear, guys. So any more doubts, any more questions? Okay. Now, let me just proceed with the next one. Now we have 8 planets in our solar system, right? So please don't count Pluto as planet. Pluto is a dwarf planet, and I'll explain to you why Pluto is a dwarf planet. Please don't worry about that. So we have 8 planets in our solar system, starting with Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Okay? Now, these 8 planets can be grouped into 2 groups. The first group is inner or terrestrial planets. Clear? Now, on the basis of their distance from the sun and other broad similarities, the 8 planets in the solar system fall into 2 groups. And the first group is the inner planets or the terrestrial planets. So in this group, we have 4 planets: Mercury, Venus, Earth, and Mars. So these 4 planets belong to the terrestrial planets or the inner planets. And they are also rocky planets. What do you mean by rocky planets? They have a rocky surface. So these planets are solid, okay, and they have a rocky surface. So we call them as rocky planets. Clear? Now, what are the characteristics of the inner planets or the rocky planets? First, they have smaller masses. Now, the Earth is very small compared to Jupiter. Jupiter, Saturn, Uranus, and Neptune. These 4 planets have very high masses. These are very large planets. So, compared to these 4 planets, Jupiter, Saturn, Uranus, and Neptune, Mercury, Venus, Earth, and Mars are very small. They have very small mass. Clear? Next, they have higher densities. Now, what is the meaning of this? Jupiter, Saturn, Uranus, and Neptune, they are gas giants. They are made up of gases. But Mercury, Venus, Earth, and Mars, they are rocky planets. They are solid. So these planets have higher densities, but they have small masses. So that is what you're supposed to understand here. So anyway, for the sake of clarity, let me just repeat this one more time. The inner planets or terrestrial planets, Mercury, Venus, Earth, and Mars, they are solid. So they have higher density, but they have less mass. Now, Jupiter, Saturn, Uranus, and Neptune, these are gas giants. They are made up of gases, and these planets are very huge. So these planets have higher mass, but they have less density because they are made up of gases. Clear? So, the second characteristic of inner planets is higher densities. Because these are rocky planets, they are made up of solid. Next, these planets have slower speeds of rotation. What do you mean by rotation? Planets spin around their own axis. That is rotation. So just look at the rotational periods of these inner planets. Mercury. Mercury finishes one rotation around its own axis in 58 days and 15 hours. Venus, just look at Venus. It takes 243 days to finish one rotation around its axis. So it is the longest in the solar system. I hope you're understanding. Venus takes the longest time in the solar system to finish one rotation around its axis. It takes 243 days to finish one rotation around its axis. Now, Earth, our home planet. Earth takes 23 hours, 56 minutes, and 4 seconds, roughly 24 hours, to finish one rotation around its axis. And Mars takes 1 day, 37 hours to finish one rotation around its axis. So these rotational periods are slow. When we compare these rotational periods with the rotational periods of gas giants, then you'll understand how slow these rotational periods are. Clear? And then these rocky planets have less number of satellites. For example, Earth has only one natural satellite, Moon, and Mars has two natural satellites. These are actually asteroids. These are very small in size compared to that of our Moon. And these names are Phobos and Deimos. So these are the names of satellites of Mars. Clear? Now, Mercury and Venus, they don't have any satellites. Please keep this in mind. Earth has one natural satellite, our Moon, and Mars has two natural satellites, Phobos and Deimos. So these are the characteristics of the inner planets or terrestrial planets or rocky planets. First, they have very small masses. Second, they have high densities because these planets are made up of rocks. They have rocky surface. They are solid. So they have higher density. Next, these planets have slower speeds of rotation. When we compare these rotational periods with that of Jupiter, Saturn, Uranus, and Neptune, then you'll understand how slow these rotational periods are. And then these planets have less number of satellites. Mercury and Venus, they don't have any satellites at all. Earth has one natural satellite, our Moon, and Mars has two natural satellites, Phobos and Deimos, which are very small. Clear? So guys, any doubts anybody has? Okay, so if you have any doubts, please ask me now. Mudit, you have any doubt? Okay, so this concept will be more clear to you when we discuss the gas giants. So let me just go to that now. The second group is outer planets or gas giants. So they include four members, Jupiter, Saturn, Uranus, and Neptune. Now, what are the characteristics of these gas giants? First, they have very large masses. So these four planets are very, very large compared to the four terrestrial planets, Mercury, Venus, Earth, and Mars. Clear? So they have very large masses. And these planets have faster rotations. So just look at the rotational periods of these planets. Jupiter finishes one rotation in 9 hours and 50 minutes. Saturn finishes one rotation in 10 hours and 14 minutes. Uranus, 17 hours and 14 minutes. Neptune, 16 hours and 6 minutes. So see how fast these planets are rotating around their axis. Now just compare these rotational periods to the rotational periods of terrestrial planets. Mercury is taking 58 days and 15 hours. Venus, it is taking 243 days to finish one rotation. It is the slowest in the entire solar system. Earth 24 hours and Mars 1 day and 37 minutes. Okay? So the gas giants have much faster, the gas giants have much faster rotational periods. Clear? Now, these planets also have a large number of satellites. So we will discuss that now. Please don't worry. And these planets are made up of gases. So that is the reason they have low densities. Clear? Like for example, Saturn. Saturn has the lowest density in the solar system. Now just imagine that there is a huge lake that is made up of water. If you just leave Saturn on that lake, Saturn will simply float. It will not sink. So just imagine that there is a huge lake made up of water. If you just leave Saturn on that water, Saturn will simply float, but it will not sink. So that is the lowest density Saturn has. Clear? So what are the characteristics of these outer planets or gas giants? First, they have very large masses. These four planets, Jupiter, Saturn, Uranus, and Neptune, these are very large compared to the inner planets or terrestrial planets. Second, they have much faster rotations. So just look at these rotational periods. And next, they have higher number of satellites. We will discuss that now. And they also have much lower densities because these planets are gaseous planets. They are made up of gases, mostly hydrogen, helium, and the other gases. So they have much lower density. Clear? Now, Saturn has the most moons, 82, and Jupiter has 79 moons. So just look at the moons of Jupiter: Io, Europa, Ganymede, and Callisto. These are the four moons of Jupiter which are very prominent. These are actually visible from small telescopes also. These are the four most prominent, largest moons of Jupiter. And they were first observed by a person called Galileo Galilei. So these are also called the Galilean moons. Galileo Galilei was an Italian astronomer. So using his telescope, he first observed these four moons. So these are also called the Galilean moons. Clear? Now, Saturn has the most moons in the solar system. Saturn has 82 moons. And out of the 82 moons of Saturn, Titan is the most unique and special one. Now, the atmosphere of Titan can be compared to that of the atmosphere of Earth, okay, in terms of thickness and height. And also, we have lakes, rivers, seas, and oceans, right, on Earth. In the same way, on Titan also, there are lakes, rivers, oceans, and seas, but they are not made up of water, they are made up of hydrocarbons like methane. Clear? So, any doubts anybody has, guys? Okay, so tell me what doubts you have. I'm going to address your doubts now. So, sir, why these planets have different rotational speed? Okay, so for you to understand this, you have to understand astrophysics. So please let us not go into physics because UPSC is completely a non-technical exam. It won't ask you any physics-based questions. Okay, so just give me 1 second time. I'll get back to you. Okay, so sorry for that. So, any more doubts anybody has, guys? Tell me now. Please don't ask me physics-based questions. I can clear that, but UPSC is totally a non-technical exam. It won't ask you any physics-based questions. If you have understood whatever I'm telling, that is more than enough. Please trust me. I've written 4 mains till now, so my experience will help you in cracking your exam. So just trust my word. So you don't have to memorize the names of any, satellites. You just have to memorize the names of some important satellites like Titan. Titan is an important satellite of Saturn, right? So Titan is special, Titan is important, and NASA is planning a mission to Titan. So if there is any other body apart from Earth in the solar system which can have life, then it is Titan. I'm not saying that there is life on Titan, but there is a probability that life might exist on Titan. Okay. And NASA is planning to send a space probe to Titan. So such type of important things you have to remember. Okay. So why is Mercury and Venus's rotation on axis take such a long time? So Aditya, your doubt is a very simple doubt. Let me just explain that. Mercury and Venus are very close to the sun. So these are under immense gravitational pull of the sun. So that is the reason these planets spin very slowly. There might be several other reasons also, but this is what I know. But please let us not go into any physics questions. So we are preparing for UPSC IAS exam, which is totally a non-technical exam. They won't ask you any technical questions. Please don't worry. Okay, so any more questions anybody has? So some students are asking me to explain in Hindi, but I was told that this is an English medium session. So please discuss with management about that. Okay. So this is going to be an English medium class. That is what I was told. So if you have problem with English, kindly discuss with the management. That is my request. So any more doubts anybody has? Just ask me now. Any more doubts, any more concerns? Let me just clear it now. Okay. So just don't go into any physics questions. Just try to understand the concepts which I'm trying to explain here. That is more than enough. Physics, chemistry, biology, these are not asked in UPSC. Even questions in science and technology are asked only for application. Okay, like for example, if there is hydrogen fuel cell, that is in news recently. UPSC will not ask you to explain the principle of hydrogen fuel cell. UPSC will ask you where hydrogen fuel cell can be used. What are the advantages of using hydrogen fuel cell? So all the questions in science and technology are application based questions. They won't ask you any physics, chemistry and biology principles. So please don't worry about that. Okay? Okay, so I'm continuing in English only. Now, let me just proceed the next one. Now, the Earth is the third nearest planet from the Sun. It is also the fifth largest planet in the solar system. And please keep one thing in mind, the Earth is the densest planet in the solar system. Okay? So, Earth is the densest planet in the solar system. Please keep this in mind. Now, planet Venus is called the Earth's twin because of its similar size. So, just look at Earth and Venus here. They have similar size. Venus is only slightly smaller than Earth. Okay? And Pluto is a dwarf planet as designated by the International Astronomical Union. So, International Astronomical Union is an international body that is made up of professional astronomers from various countries. So, this international body takes decisions regarding the naming of planets, whether, deciding that this body should be a planet or a dwarf planet. So, all such decisions are taken by the International Astronomical Union. Clear? Now, just look at these two images for comparison. See how small the Earth is compared to Jupiter, Saturn, Uranus, and Neptune. Earth is very, very small. Okay. Now, just compare Earth with Pluto. Pluto is even small. Pluto is smaller than Mercury. You can see Mercury in this image, right? Now, Pluto is even smaller than Mercury. So now you might have understood why Pluto is not a planet. Pluto is a dwarf planet. Clear? Now, what is the status of Pluto? Pluto was discovered in 1930 and it was given the status of ninth planet in the solar system. But in 2006, the International Astronomical Union designated Pluto as a dwarf planet. Now, what is a planet according to International Astronomical Union? So, according to IAU, a planet must meet three conditions. First, it must revolve around the sun in a well-established orbit. Second, it must be massive enough to be a sphere under its own gravitational force. So, what is the meaning of this? Planets are spherical in shape because planets have a large mass. Due to this large mass, there is a lot of gravitational energy. This gravitational force will shape the planet into a sphere. I hope you're understanding. So, a planet must be massive enough to be a sphere under its own gravitational force. And next, it must have cleared the neighborhood around its orbit. It means it must not intersect the orbit of other planets or satellites. These are the three conditions for a planet. Only if these three conditions are met, a body will be called a planet by International Astronomical Union. Now, what is the meaning of this third point? Let me just explain this. Now, for example, consider Earth. Earth is a planet, right? Is Earth crossing the orbit of any other planet? No. Earth has its own orbit. And there is no other planet which is nearby Earth. Earth is not crossing the orbit of any other planet. Clear? and the space around the Earth is empty. But Pluto is not like that. Pluto, in its space around, there are many more objects like Pluto. So Pluto is not massive enough to clear its neighborhood. I hope you're understanding. Like, for example, if any other object comes close to the Earth, it will either fall into Earth or the Earth's gravitational pull will push it away. I hope you're understanding. But Pluto is not like that. Pluto is so small that its gravitational energy is not sufficient to clear other objects in its orbit. So that is the meaning of the third point. Okay, so I hope this is clear. Know this factual data. There is no need for you to mug up this factual data. Okay, just understand the concept, that is more than enough. Now, I hope you understood the three conditions. Pluto meets the first condition and the second condition, but Pluto does not meet the third condition. So Pluto cannot be called as a planet. Pluto is a dwarf planet. Clear, right? Now, Pluto is not massive enough to meet the third condition. And Pluto is considered to be the largest object of Kuiper Belt. So what is Kuiper Belt? We'll discuss now. Okay, first let us discuss what are asteroids and then we'll discuss Kuiper Belt. So we will discuss Kuiper Belt when we discuss comets. We have to discuss about comets also, right? So right now, let us just continue with our discussion. When we discuss comets, we'll discuss about Kuiper Belt. Clear? Yes. So, what are asteroids? Asteroids are rocks revolving around the sun that are too small to be called planets. So between the orbits of Mars and Jupiter, you have some millions of asteroids revolving around the sun. And these are rocks. These are not large to be called as planets. They are not even large enough to be called dwarf planets. These are just rocks which are revolving around the sun in the space. There are millions of asteroids ranging in size from hundreds of kilometers to few feet across. Okay? And they are found between the orbits of Mars and Jupiter. So this area is called the asteroid belt. Clear? So I hope you understood what are asteroids. These are just rocks that are made up of dust, ice, and minerals. And these are very small. They cannot be called as planets. They cannot even be called as dwarf planets. These are very small. And there are millions of asteroids in space between the orbits of Mars and Jupiter. So this area is called the asteroid belt. As simple as that. So moving on to the next one. Recently, on 20th October 2020, NASA spacecraft OSIRIS-REx, it approached an asteroid called Bennu. Now, Bennu is a carbon-rich asteroid. So, OSIRIS-REx landed. It did not exactly land. It touched the surface of Bennu. It collected samples and then it went off. Now, Bennu is a carbon-rich asteroid. The asteroid Bennu is made up of carbon compounds. So, scientists say that if you analyze these compounds collected from Bennu, it might reveal the secret behind forming of solar system. So that is what the scientists say. So the sample, according to the scientists, will help us in understanding the origin of solar system. Clear? Now, let us discuss about meteors. So here we'll discuss three terms: meteoroid, meteor, and meteorite. Three terms are there. First is meteoroid, second is meteor, and third is meteorite. Let me just explain the difference between these three terms. Now, sometimes two asteroids will collide with each other, which will lead to breakup. Small pieces will be formed. Those small pieces are called meteoroids. Clear? I hope you're understanding. Sometimes two asteroids will smash into each other. First, there are millions of asteroids in space between Mars and Jupiter. They're all revolving around the sun with very high velocity. So there is a very good chance of collision. So sometimes two asteroids will collide with each other and they'll break up into small pieces. Those small pieces are called meteoroids. Clear? Now, sometimes these meteoroids will come close to the Earth and they get pulled by the gravitational pull of Earth and they will enter into the atmosphere and they will start falling towards the surface. So these meteoroids will move through the atmosphere with very high speed. Now the atmosphere is made up of gases. It is not vacuum. It is made up of gases. So these gases will offer friction to the movement of meteoroid. So a lot of heat is generated and the meteoroid will get burnt up. Then it forms a streak of light like this. Then we call it as meteor. Clear? Now, in most of the cases, the meteor will get burnt up. But sometimes some resistant part will remain and it will fall to the ground. The tiny piece is called meteorite. So that is the difference between meteoroid, meteor, and meteorite. Clear? So let me just explain this one more time. Asteroids collide with each other. Those tiny pieces are called meteoroids. Okay, meteoroids. Sometimes the meteoroids will come close to the Earth and they will get pulled by the Earth's gravitational pull. So they'll start falling through the atmosphere with very high speed. So due to friction, a lot of heat is generated and the meteoroid will get burnt up. Then it forms a streak of light or a beam of light called meteor. We also call it as shooting stars. Clear? Now, most of the meteors will get burnt up, but sometimes some small part will remain and it will fall to the ground. Then you call it as meteorite, as simple as that. So I hope you understood this. So just look at this. So this is a meteor which is falling through the atmosphere. Once it falls to the ground, those tiny pieces are called meteorites. And this one is a meteor. Clear, right? So I hope this concept is clear. So any doubts anybody has, please ask me now. So we have last 10 minutes left. So if you have any doubts, ask me now. And then again, we'll continue. So thank you, Prahlad, for your compliment. All these are to help you guys to understand better. So Nitish has asked a doubt. Are these harmful for the Earth's atmosphere? Not exactly. They're not harmful. It happens for every planet. Yes, Lunar Lake formation. Lunar Lake is due to the collision of a meteor. It is an impact crater. We will discuss about the lunar crater when we discuss lakes, the different types of lakes. Clear? Do we need to cover anything apart from your PPTs? No. As of now, for this class, the content which I'm giving you is more than enough. If you have to cover anything else, I will definitely tell you. Just have trust on me. Okay. So, proceeding now. What are comets? Comets orbit the sun, same like asteroids. You have understood what are asteroids, right? So, same like asteroids, comets also orbit the sun. They revolve around the sun. Now, comets are made up of ices such as water, carbon dioxide, ammonia, and methane mixed with dust. So, here the meaning of ice is different. The meaning of ice, which we know, and the meaning of ice according to astronomy is different. In astronomy, ice means volatile compounds such as ammonia, methane. Okay, so these volatile compounds are ices in astronomical terms. Clear? So comets orbit the sun like asteroids, and comets are made up of ices like water, carbon dioxide, ammonia, and methane mixed with dust. All these materials came from the time when solar system was formed. Simple, right? So this is how a comet moves through space. We'll also discuss about the tail of the comet. Please don't worry about that. Now, scientists say that comets have originated from the Kuiper Belt. So what is Kuiper Belt? So this is Kuiper Belt. Okay? Kuiper Belt is a disc-shaped region past the orbit of Neptune. So this is the orbit of Neptune. So beyond the orbit of Neptune, there is a disc-shaped region that is made up of rocks. That is nothing but Kuiper Belt. Now you can think of Kuiper Belt like asteroid belt. But the only difference between Kuiper Belt and asteroid belt is Kuiper Belt is at least 20 times wider than asteroid belt, and it is at least 200 times more massive than asteroid belt. Clear? Let me just repeat this one more time. You can think of Kuiper Belt like the asteroid belt. The only difference is Kuiper Belt is at least 20 times wider than asteroid belt and at least 200 times more massive than the asteroid belt. So Kuiper Belt is a very, 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 very large area. It is made up of some billions of rocks like this, as shown in this image. Okay? Now, Kuiper Belt is a disc-shaped region beyond the orbit of Neptune, extending roughly from 30 to 50 astronomical units from the Sun. The orbit of Neptune is 30 astronomical units from Sun. So Kuiper Belt extends from 30 to 50 astronomical units from the Sun. I hope you understood this. And this belt contains many icy bodies which can become comets. So that is how comets form. Clear, right? Now, we know that comets are made up of ices such as water, carbon dioxide, ammonia, methane. Now, these comets revolve around the sun. Just imagine this to be the sun, and this is orbit of comet. Now, the orbit of comet is elliptical. Okay? So, sometimes the comet is close to the sun. Sometimes the comet is close to the sun, and sometimes the comet is far away from the sun because the orbit of the comets is elliptical. This is ellipse, a rough diagram. So when comets come close to the sun, due to the heat of the sun, these ices will get melted and they will form a tail behind the comet. So that is how comet's tail is formed. Clear, right? So I hope you understood this. Any doubts anybody has still here? Please ask me now. Okay, so any more doubts? Anybody has no more doubts? Yes, universe was formed due to Big Bang. Actually, there are many theories which explain the formation of universe, but Big Bang theory is the most widely accepted theory. Okay? So any more doubts, guys? No more doubts? So let me just continue. So I hope you understood what are comets and what is Kuiper Belt. All these concepts are very important. These have been asked in the exam previously. So please don't take them lightly. Now, what is Goldilocks Zone? Now, as far as we know, Earth is the only planet which can support life. As far as we know. Now, the universe is very huge. There might be many more planets out there which contain life. But as far as we know, Earth is the only planet which can support life. As far as we know. Because we did not discover any alien life yet. Maybe in the future we might discover, we don't know. But as far as we know, Earth is the only planet which can support life. Why? The Earth is the third planet from the Sun, and it is not too far and not too close. Okay, if the Earth is very far away from the Sun, then Earth would be very cold and life cannot exist. If the Earth is very close to the Sun, then the Earth would be very hot and again life cannot exist. So the Earth is not too far, not too close. It is at a perfect spot from the Sun. It is the third planet from the Sun. So the Earth is in the habitable zone or Goldilocks zone. So what is this Goldilocks zone? The Goldilocks zone refers to the habitable zone around a star where temperature is just right. The temperature is not too hot or not too cold for liquid water to exist on the planet. So that is the meaning of Goldilocks zone. So just look at this image. The red color zone indicates that the planet is too close to the star and the planet's temperature is very hot. So liquid water cannot exist. The blue color zone indicates that the planet is very far away from the star. So the planet is very cold and liquid water cannot exist. This green zone indicates that the planet is at a perfect spot, correct distance from the star, where the temperature is not very hot, not very cold, and liquid water can exist on the planet. So that is the concept of Goldilocks zone. Clear, right? Okay, so Mudit, what is your doubt? As comets follow elliptical paths and sometimes cross other planets' orbit, how could they even survive after crossing the other planets? Other planets' orbits, as these are not so dense and heavy in comparison to the other planets. Okay, so Mudit, you are saying that comets will sometimes come very close to the planets. So how can they survive that? So yes, if asteroids or comets come very close to the planet, then they'll get pulled by the planet's gravitational force. Okay. So Jupiter is the largest planet in the solar system, and Jupiter's gravitational pull is very immense. So if any comet or asteroid comes close to Jupiter, it will immediately fall into Jupiter. It will collide with Jupiter. Okay. So we are only talking about comets which do not come close to any planet. See, the space is very, very vast. There is a lot of empty space between one planet and the other planet. Okay, so please think in that way. So, any other doubts anybody has? No more doubts? Okay. So, I hope you understood the concept of Goldilocks zone. It is actually one of the previous year questions. So, just keep this, image in mind. Red zone indicates planet is too hot. The blue zone indicates the planet is too cold. The green zone indicates that the planet is at a perfect spot. It is not too hot, not too cold, and liquid water can exist on the planet. So that is the concept of Goldilocks zone. Clear? So guys, I hope you found this session useful and informative. I hope you enjoyed this session. Thank you so much for joining me. And we'll again continue with this session tomorrow, where we'll discuss some more interesting topics. And once we are done with the first chapter, solar system and the Earth, we'll jump to the second chapter, which is the interior of the Earth, where we'll discuss about the various layers of the Earth, crust, mantle, core, and how the temperature, pressure, density changes, and how did we get so much information about the Earth's interior? What are the sources? So all these interesting topics we'll discuss in the next session. So before I end this session, anybody has any doubts? No more doubts? So thank you so much for joining me. Good night and take care.